So today in computer networks, we are going to discuss about various topologies like star, bus, tree and mesh. So first topic is network topologies. It is the pattern of interconnection of nodes in a network. As you can see, there are various patterns as shown in the image in which different nodes are connected. You can have bus, star, ring, mesh, tree, point to point, etc. Let us see them one by one. Now, types of topologies. We have two types of topologies: physical topology and logical topology. So, physical topology is the physical shape or layout of the wires that can be visible in a network. The physical topology defines how devices are interconnected with or without wires. It is further divided into two sections: point-to-point connections and multi-point connection. So first is point-to-point link. As you can see the image, in a point-to-point connection, a communication link is established between two devices with one wire, or it can be wireless. So that is why it is a simple point-to-point link. A simple example of point-to-point connection is talking over telephone between two persons where anyone else is not allowed to use the phone on either side. Then we have multi-point link, in which multiple devices or machines are involved in a multi-point connection. These devices mainly share cabling, but each device needs to have a unique number like IP address to identify each other for sending data between them. A good example of multi-point connection is communication between a group of computers in a network. See, this can be an example of multi-point link in which various computing devices can be connected with multiple machines. So these were physical topologies. Now let us see logical topology. A logical topology defines how devices communicate with each other across the physical topology. Physical topology means just arranging cables and devices in a particular pattern. The physical and logical topologies are independent of each other. Physical topology refers to physical layout of wires, whereas logical topology refers to how data moves through the network. And for this, we have five different types of logical topologies: star topology, hierarchical topology, or it is also known as tree topology, bus topology, mesh topology, and ring topology. But we are going to discuss only four topologies which are in your syllabus. So let us start with a star topology. A star topology contains a central hub. As you can see the image, this is your central hub, a device which is used to connect each and every node. So this is your central hub. Let us see some points of star topology one by one. A star topology is established with a central connection point called a hub node. Second point, the hub may be an actual hub device or sorry, or a network switch or a network router. Network devices generally connect to the hub with unshielded twisted pair Ethernet cables, also known as RJ45 cables. Normally what you see in computer labs are Ethernet cables, which are known as RJ45 cables, because these get inserted into a particular jack whose name is RJ45 jack. Last point, the main benefit of a star network is that failure in any star network cable will only take down one computer's network access but not the entire LAN. It means suppose this computer fails. In that case, this will not be able to use network resources, but the whole network will not get disturbed. It will keep working. However, if the hub node fails, obviously, if this fails, what will happen? The entire network will be down. So this can be a drawback in a star network. Now let us see advantages and disadvantages of this star topology. First is advantages. Centralized control of network is there. Second advantage, it is easy to find and correct errors. Third, if one computer fails, it will have no effect on other computers on the network. And the fourth, access protocols are very simple because we have one-to-one connection with cables. So access protocols are very simple. But we have some disadvantages like long cable length. So it will cost a lot. If the hub fails, then the whole network is stopped. Wiring closet is required because there are so many wires. Yesterday also I showed you some images. You saw there are so many wires. For that, wiring closet is required to look it neat and clean. So this can be another expense. And fourth is difficult to expand. If you want to add some more computers, it becomes difficult in a startup project. Next is bus or linear topology. You can see the image. We have a file server connected with a backbone or main wire, main cable. This backbone is having terminator at both the ends. So this is in a linear fashion. That is why it is called linear or bus topology. Let us see some points. In a bus network, a common backbone is connected to all network devices. The high capacity bus backbone, generally a single cable, functions as a shared communication medium and it joins networks and central devices. It means we can connect a whole network with this backbone also. Third point, if any network device wants to communicate with another network device within a bus, the device sends a broadcast message onto the backbone. All other devices will see the broadcast message, but only the desired recipient will accept and process the message. Suppose this node 1 wants to send a message to this node, let us say node number 7, randomly. Then the message will go through this backbone and every node is able to see that message. But whether it is able to read that message or not, it depends on the authentication. So if some security features are there, then it will not. Then it will reach this node. This 7th node will accept it and process the message. It means it may give an acknowledgement to system number 1 or node 1 that message has been received. Fourth, failure of the backbone cable will damage the whole network. See, this is an image of bus topology. We have some hardware showing here. These are T connectors, and this is your terminator, and a terminator looks something like this. This is a terminator with a particular grounding wire for earthing, something like this. It is used to stop the signals. See here, it is shown NIC card. This is your NIC card, which is inside CPU, and using cable or like coaxial cable, we can connect this NIC card with this bus. Here connection can be done using coaxial cable. Again, this is a T connector. Okay, now let us see advantages of bus topology. It requires less cable length than star topology, so it is cost effective. It is easy to add new node. That means it is very easy to expand. Just remove the terminator, add another cable, backbone cable, and start joining new nodes. So it is quite easy. But we have some disadvantages. First, entire network shuts down if there is a break in the main cable. Second, terminators are used, sorry, terminators are required at both ends of the backbone cable. Third, it is difficult to find out the problem if the entire network shuts down. That is, fault diagnosis is difficult. Once you have found a faulty node, then fault isolation is also difficult. This is another disadvantage. Next we have a tree topology. There are two more topologies in your syllabus. In tree topology, we have one main root node along with some nodes connected just like branches of a tree. That is why it is called tree topology. Normally, a tree topology is a combination of star topology and bus topology. Let me show you how. I need to make a small diagram in that case. Okay, I am sharing another screen. Okay, let me make it here only. Okay, I am trying to make a tree here. So let us suppose this is a backbone cable, right? And with this we can have connections like this. Now suppose this is a hub or switch, and we have let me change the color. Various nodes. This is node 1, this is node 2, this is node 3, like this. And with the red color I am showing you a hub or switch. Now I am going to connect these with wires. This gets connected with this. These are 3 nodes. There we have 4 nodes. So if you see, this is a combination of star topology and bus topology. We have 1, 2, 3, and 4. 4 stars here. No? Star topology 1, star topology 2, 3, and 4. All these star topologies are getting connected with a backbone. So it becomes a bus topology. So here we have branching. So it is arranged in a tree fashion. So this is also a diagram of tree topology. So let us see what is written here. In tree topology, the devices are arranged in a tree fashion similar to branches of a tree, right? Devices at lower levels are connected to devices at next higher level, which resembles like a tree like structure. At higher levels of the tree, often point to point or point to multi-point connection. Okay, let us come back. Okay, now advantages of tree topology. First, it is a combination of bus and star topology, which gives advantages of both the combination. Second point, it provides high scalability as leaf nodes, leaves branches, as leaf nodes can add more nodes in the hierarchical chain. Third, other nodes in a network are not affected if one of the nodes get damaged. So this is the benefit of tree topology. Fourth, it provides easy maintenance and fault identification is also easy in this case. And here we have point-to-point wiring for individual segments as you saw in the diagram which I made earlier. Disadvantages: large cabling is required as compared to star and bus. In star topology we have large cable length. In bus also we have cable length. So obviously cabling is added up. Second, on the failure of a hub, the entire network. Third, tree network is very difficult to configure than other network topologies. It becomes very complex. You are combining bus and star both in tree topology. So obviously it will be quite difficult to maintain it. Fourth point, as more and more nodes and segments are added. Segments means LANs. For example, in previous diagram I made star topologies. Star 1, 2, 3, 4. These can be considered as segments. So as more and more nodes and segments are added up, the maintenance becomes quite difficult. For all this, we need experts. Now, this is the last topology for your syllabus, mesh topology. In our book, we have mesh topology. See this figure. A particular node can be connected to other nodes so that we can get multiple routes or paths for the messages to travel. A mesh topology is a network topology in which all the network nodes are individually connected to most of the other nodes. यहाँ लिखा है most of the other nodes, not all the nodes. It is not compulsory. If each and every node is connected with each and every other node, then it is known as fully connected topology or fully connected mesh topology. Right? This is the only difference. Second point, there is not a concept of central switch, hub or computer, which act as a central point of communication to pass on the message. Third point, it provides an alternative route in case the host is either down or too busy. Advantages, each connection can carry its own data load. Fault diagnosis is done easily. It provides security and privacy. It manages high amount of traffic because multiple devices can transmit data simultaneously because there are so many connections. Fifth point, a failure of one node does not cause a break in the network or transmission of data. If one node is not working, still network will work. Adding additional devices does not disrupt data transmission between other devices. So there is no problem at all in the expansion of mesh topology. If you want to add a node, it is quite easy. If you want to remove a node, it is also quite easy. Fault diagnosis is also easy. Fault isolation is also easy. Now, disadvantages of mesh topology. The cost to implement is higher than other network topologies, making it a less desirable option. Building and maintaining the topology is difficult and time consuming. Third, the chance of redundant connections is high. Redundant means duplicate connections because there are so many connections. Now, one is connected to so many nodes, so there are chances of redundant or duplicate connections, which adds to the high cost and potential for reduced efficiency and even security. So this is the last one, but not in your syllabus. It is related to mesh topology, that is why I have included it. Fully connected mesh topology. A mesh topology is a network topology in which all the network nodes are individually connected to most of the other nodes. I think this has been repeated here. I need to make some changes in this. Fully connected mesh topology says if each and every node is being connected with each and every other node, that mesh topology becomes fully connected mesh topology. That's it.
Good morning, sir.
Good morning. You are so
Good
late.
morning, sir.
So with this, I finish part 2. Now in part 3, I will try to finish this whole chapter.